Hello everyone. Getting your cloud right promises you deep dive into various aspects of cloud, but most importantly, getting it right at the first time itself will be the focus of today's discussion. Today I have Suhas Joshi with me, who is VP Technology at Harbinger Systems and very much passionate about cloud. It would be delighted to hear him about how industry is adapting and coping up with the growing demand of cloud, and most importantly, leveraging it the right way. Welcome, Suhas.
Thanks, Umesh. I think discussing on doing it right is definitely an exciting topic for me.
Glad to have you, Suhas.
Thank you.
So, Suhas, cloud technology has been there for more than a decade now, and many new products are maybe just born in cloud, or some of these are maybe still planning to move or may have a hybrid scenarios as well. Also, often we have seen products are continuously innovating and they are leveraging many sophisticated services from cloud service providers as well. So, all these requires quite deep considerations for doing it in the right way. So, I think doing it right has always been important, hasn't it?
Yes, Umesh, doing it right has always been important. But with every change, you need to also adapt ways of doing it right. So if you look at cloud era, basically end users as well as the product developers take it for granted that high availability, infinite scalability. So with in the cloud era, everybody takes high availability, infinite scalability for granted, and they also want to make quick and faster enhancements to the product. And end users have started to also think that that is something which is a must-have. Now that means that you have to also define what it means to get that right. Now if we look at the history of software engineering, then you can see that in the history, the software engineering community has actually adapted the processes or adapted ways of doing it right whenever there was a new demand on the quality of the software. So I think there is a lot of learning from there which we can take forward.
Definitely, Suhas. I think you like to go back to the roots to connect the dots here. So maybe it would be good to get some more examples about how do you see the overall evolution of the software engineering in the era of cloud here.
So actually looking back and looking forward has helped me a lot in my career, so that you can get best things from the past and then apply them going forward. So I'll give you some examples of how in history software engineering community has done that. So if you look at OO technology, when OO technology came in, there was also along with that a lot of promise about creating reusable code, which means overall the product owners wanted to do it at speed because you're going to reuse components. But it turned out that it was not to be, because there were no patterns at that time. And that's when Gang of Four Patterns book, which came in around 94-95 time frame, that set the things right. And product owners, framework designers picked that up. So you saw the patterns getting into frameworks, getting into programming languages. That made it easy for developers to create more complex software in less time. Similarly, in that era, even the way in which we manage customer requirements and the way in which we deliver, how do we keep customer in touch with what is going to show up as delivered software? So the community was struggling with that in the waterfall model era. And then that process or methodology went through waterfall to iterative to spiral to JAD development methods, rapid application development methods. And here we are with cloud in terms of agile development method, where customers can see that they are getting what they want in time frames of 2 weeks, 3 weeks, or a month. And they don't have to really wait for 6 months to 9 months. So that is another improvement that looking at the problem that the community found. The third thing we have seen is as software development teams started getting bigger and bigger, there were methods and processes and tools that came in the development part. So you had version control systems, then build tools, deployment tools, test automation tools. And all of that eventually got together in an automation which led to continuous integration and continuous deployment, CI/CD term that we sort of caused. So essentially in the cloud era now, what we have to understand is how are some of the features delivered by cloud service providers, how are they getting consumed in the applications, and note down any nuances that have got introduced in this technology compared to the earlier mechanisms, and adapt the doing it right from there. So it was always important, but it also always needed to adapt, and we have seen that happen in the history.
Very true, Suhas. This agile, faster release of products is more pushing developers to also wear operations hat. So, do you have any views on what are the critical aspects that developers now need to think about, and whether it would change if they are yet to plan for the cloud or they are already on the cloud?
Yes, Umesh. I'll explain you how I look at this. If we start with a deployment view of the architecture, then we know that each of the components in the architecture is actually mapped to the deployment. Now, in the cloud era, that means it could be mapping to infrastructure as a service components, or platform as a service components, or a function as a service components. And cloud providers even go beyond that to give you certain services which would have required multiple components in your deployment architecture, like messaging and stuff like that. So with that, what happens is, as you rightly said, that developers come closer to the operations, which means that operational monitoring aspect of all these cloud services that we consume, that becomes very important to be related back to which components are doing what. So that is one thing that comes out of that higher level of abstraction that I used. Now, if we take a look at function as a service as an example, that if a component earlier used a mechanism where certain functions in their applications were triggered, either on messages arriving in message queue or something else, they would have had different kind of components in their deployment architecture. One for file, one for timer going off, other for things like messages coming in. Now with cloud, function as a service gives them that abstraction, which allows them to do that. Now if we use that as part of a user action, then because the entire infrastructure is managed by the cloud service provider, the moment that function ends execution, that entire infrastructure is not available for you to even query anything. Which means the way you do logging needs to change. You have to pay attention to logging the context in which the function was called. And if you do that, that eventually helps you in field debuggability. So that is one thing which one can look at. Earlier, all of that was directly possible by logging on the disk that was available. So you need to change that and pay attention to that. Other aspect is this function invocation is again part of a bigger user action. Now if we take a performance point of view, then you also need to look at what metrics you need to gather before the function execution ends, so that any other performance related analysis to be done on the entire application will have enough information for that. So that is one thing which you have to pay attention to. Yeah, so we talked about field debuggability and performance. So that is something which is critical. Yeah. So again, another thing to look at for the function as a service thing is the fact that cloud provider tells you that you have to be worried about cold start and warm start. You have to be worried about number of calls, concurrent calls that a function can have. Now, if you look at it in the past, we didn't have to worry about that because we created threads ourselves on the infrastructure which we had deployed. Now, these restrictions are placed by the cloud provider so that they can manage these things well. So now as a developer, I have to start worrying whether the cold start of a function is going to cause delays in user action. And if it does, then I have to make sure that I employ strategies to make it warm startable functions. Because otherwise, after infrequent requests going to that function, the cold start again kicks in. Which means these are some considerations that you have to put in right for your performance engineering part. So I think you take good things from the past and look at specific cloud features and how it has changed or whether it has put any constraints on you, and then adapt those things. And that's where I found the deployment view as a starting point to be very useful.
This is getting interesting now, and you rightfully brought the architectural view to describe the change in the process. Would there be some more examples that will help understand how the transition from maybe the legacy systems to the cloud environments?
Yes, sure. So Umesh, if you recall, in pre-cloud era, we have worked with a lot of customers where we built multi-tier systems. So essentially those were following layered architecture patterns, and the deployment view of those architecture was either 3-tier or multi-tier, depending on how many layers, how many tiers of say data access or business layer you have. So we worked with those, and we have seen examples of those things. Now, if those kinds of products have to move to cloud, if you look at the deployment architecture, if you have that view properly in place, then there is a possibility that you can take that and one-to-one map with the cloud services. For example, in your original one, suppose you had this 3-tier architecture with load balancer in front, then you can choose certain load balancing services, you can choose VMs, which could potentially be derived from your existing configurations. So that allows you to move things quickly. Typically the industry calls it as lift and shift migration. Now the consequence of that is, if you don't have optimized kind of resource allocation in the pre-cloud stage, you will carry it forward for simplicity and quickly moving to that. And that would essentially show up as potentially not being cost effective after moving to cloud. So that is one possible outcome. So what I feel is, if you also have data about usage patterns for your existing application which you are moving to cloud, then that data can be used together with the choices that you have to make sure that you make the right choices, and you also choose the infrastructure in such a way that it is optimal if you have that data. Because if you have that data, you analyze, find out what is the optimal resource requirement, and use that while going to the cloud. Now, if you don't have that also, which is likely in some situations, that data was probably gathered but no longer available. So the analyzing of that data is not going to be possible now. Now, in that case, other thing that one must do is make sure that you capture that data after doing this lift and shift migration. Because if we capture that data, it again comes in handy to understand the usage patterns, make adjustments to the resource requirements. And that is something which would essentially keep taking you in doing it the right direction step by step.
So now, with the presence of multiple cloud providers across the globe and guaranteeing availability as per their subscriptions, do we still need to do more about making sure about the availability?
Yes, we do. Let's look at the availability SLAs that the cloud providers have. So they have the SLA specifications, like if it goes below 99.5% but stays above 99%, then you get some credit. So now if we decipher this, it means that the availability going down to 99.5% should be acceptable to the users. Now if you take 0.5% of a month, it's like 3.6 hours. So now as a product developer, I have to worry about whether 3.6 hours downtime is going to be tolerable for my users, or depending on the domain of my application. If it is not, then you have to worry about that definitely. Now you have multiple things that you can do. So one is, you have to understand, monitor for failures. So those failures could be in your own components, which typically can be taken care of by exception catching, etc. Or it could be in other components in the system, or even in the another cloud service, for example, which you are using. Now, if that is not available, you will get that failure as an exception, and you need to do something about that. So one part is detection of failure, other part is retrying or recovering from that, and that is essentially your strategy, because you detected the failure and now your availability strategy kicks in. Now, if you have not thought about that, then you are not available whenever the provider's service is not available. And you are also not available when your internal components fail. So obviously, application developers have to do something about that. And for that, you have to also start with logging things. So you catch exceptions, you say that, okay, this kind of errors happen. That becomes useful later on in terms of understanding the failure conditions in your application. There is enough information after the failure. Other thing is, in terms of recovery strategy, you have to decide whether you are in a position to reduce the functionality. For example, a particular component fails, then that component may be useful only in certain features. If you have that mapping with you, which all the good architectures, they will have that information. That information can be used to just degrade the functionality, which means you say that that feature is temporarily unavailable. But at the same time, your logs and alert generation must kick in, because then the ops team can get those alerts and do something about that. So that is something, again, as a developer, you have to think, which essentially means that you need to also know where all your application can fail, either because of your own mistakes or because some other system is not being available. For example, if we take integration kind of projects, the other system may not be available to you, not because it is not up and running, but just because it is throttling. So you will get those kinds of errors. Now you need to handle those. Now what will you do? You will try to retry. Now after retries also, if it is not possible, then you need to take some action and you will need to notify your user. So in the case of integration, you need to have those mechanisms so that you can recover at a later point of time when that system is having less load and all that. So yes, the answer is we still need to also worry about availability. But cloud providers have given you availability zones. So if you are worried about their services failing, and if you want to use the redundancy kind of recovery mechanism, then you use availability zones. But again, taking that decision forces you to keep costs in mind, because availability zones are replications. And I think in the old era, anybody who has used database replication to manage such failures knows that it comes at a cost. So I see that it's not that because services are available, everything becomes available. You have to read, and different services have got those different numbers, 99.5, 99.9 and all that. Based on your application, you have to take a call, what more you need to do. But I think we have talked about different areas.
As we ensured availability, the next obvious thing to consider is it fast enough? And during talking about function as a service usage, you mentioned about multiple constraints related to services like cold start duration and so on. So can you tell us more examples about overall performance engineering strategies to adapt to cloud?
I think the way I look at this is, first we have to essentially define how a user action is getting executed in the deployment architecture. So there is a mapping from user actions to individual components participating in that, or a chain of requests, a concurrent chain of requests, which essentially completes that action. Now that needs to be known very well. Now if you know that, then you know how to find out which component was involved in a particular user action. Now if you again go back to this chain of components in deployment architecture and make sure that you have measurement at all those points, saying that how much time that component took. then you have a mechanism, you have a set of numbers which you can use to relate each component's performance to the overall application's performance with respect to a user action. Now, if you have that kind of data gathered, then you are better off in terms of identifying performance bottlenecks quickly. Now, one option teams have is to use tools which can instrument code. So at a particular level. So some of the tools instrument that at a layer level, like at the web server layer, the code is instrumented. So you get some performance numbers, more detailed performance numbers than what the infrastructure provides in terms of say CPU usage and number of requests arriving. So you get slightly more application specific thing also. So that is one option. But when you want to go down to find performance bottlenecks at the component level, then this particular mapping and more granular measurement is something which is really important, and that plays a role. Now, other thing, once you have done that, so all the post-deployment performance bottleneck resolution and all that, you are in good shape because you have got a lot of numbers, so you can quickly respond to that. But if you want to take it forward, right to the design stage, then I have seen people also looking at taking a number for user action. Like we know in the internet era, no user can wait for more than 2 seconds for the response to arrive. So if you can start with that almost for any application, and now if you apportion that 2-second thing across your components, saying that in this user action, these are the set of components that are going to play a role. You have that diagram in terms of the architecture diagram. Now you start apportioning that because these are concurrent, they can still take 600 milliseconds or whatever. Now if you apportion that, then that becomes more proactive ways of doing performance. So I think by taking such steps, you will always seek improvement in terms of doing things right. So you start measuring, you make identifying bottlenecks easier, and then you move on to sort of even setting this performance kind of constraints on your own components. And that facilitates another thing in the development, that now you can also start testing your components for load behavior, because you have defined their performance measure. So now you can also run some tests during your development process and detect some performance issues earlier. I think that should be a good way to leverage what we have already done and also take a different view. That's typically how I look at performance management. Umesh, basically with cloud providers giving you pay-as-you-go model, getting up on cloud has become very easy, and then the cost kind of implications start hitting as the usage increases and all that, as you rightly said earlier. But now if you want to optimize costs, how do you go about that? So a simple thing is, if pay-as-you-go model, if you study, it says cost is proportional to the resource usage. And there are definitions of that depending on what service you use. So you need to understand those definitions clearly. Now, if you want to optimize costs, using simple math, we'll say that if cost is directly proportional to resource, reduction of cost means if you reduce the resource, the cost will go down. But it is not always as simple as that, because sometimes the minimum resource that you have to use for certain components cannot be further reduced, and it would result in completely underutilized resource. Now, from a cost point of view, any business also worries about underutilization of resources, underutilization of capacity. So that is something which needs to be paid attention to, and that requires monitoring the resource usage at a certain level. During performance discussion, we talked about gross level monitoring available by default, like CPU utilization and certain statistics along with that. But many times for cost optimization, just using that is not good enough. You need fine-grained analysis. So you probably also need fine-grained utilization metrics. So let me give an example that we actually worked on. in terms of cost optimization. So one of our products which uses machine learning and AI based solutions had deployed the AI component on a GPU based machine. And of course there was no choice other than that, because the AI model requires that kind of infrastructure. Now when you look at that and looking at optimization, what we did is we first looked at the coarse grained charts. Now the coarse grained chart showed you that for the whole month about 30% of CPU was used as an average, because that average was on larger durations. So we had to go down. So we went down to a lowest level of granularity that was available, took that data, analyzed, and we found that for a large portion of the day, that particular resource was not used, and which led us to asking for usage patterns. Because now we wanted to find out in terms of strategy, can we shut down this resource and get the benefit? Because when you don't use the resource, then you don't pay for that. So whether those strategies can be applied by putting some additional external components in this. So that is one thing that we looked at. Other thing that we looked at is looking at the deployment architecture. We found that the rest of the components of the system which were talking to this AI module were simpler components running on simpler machines, separate machines, because that was because the deployment architecture had mapped things that way. So what we were able to do after looking at this fine-grained resource utilization was to say that those logical components can also be moved on this and increase the resource utilization. You drop those two resources. So we used the formula dropping the resources, but we did not apply it to every resource. We took a holistic view. And that kind of analysis is something that needs to be done, which means you need to be prepared for, again, connecting the overall architecture to what you see, for example. Now, if you have to sort of even take it forward, like we discussed in performance, that in order to take the right thing, do the right thing forward, to bring it even before the deployment. Now, that's where you need to start wearing a capacity planning hat. Where if you say, okay, this is my machine learning model or whatever, this component requires a 4-core machine, say. Now, what kind of load that this component will sustain with 4-core? What kind of load will I have to begin with? So if you have got your own plan for load, if you are a new product, for example, if you have that plan ready, and if you use your past experience, which architects always have, in terms of what kind of load was sustained on a particular configuration, then that comes in handy, because then you use those things to decide what kind of choices you want to make. And you may start with smaller choices and then keep growing the infrastructure, which means you have taken proactive action to actually minimize cost as far as possible right from the start. And that requires wearing those hats. So those are the things which were valued a lot. Is, for example, enterprise computing. When we go to them, they do all of that because that goes into that used to go into their budget. The pay-as-you-go model actually had some disruption over there. But I think some of these mechanisms, if they are applied, we can also bring in better ways of optimizing costs.
Thank you, Suhas. Very interesting conversation today. And I'm sure it was helpful for you as well, and there are many key takeaways for you to get started on it. We covered many aspects on cloud doing it right the first time. Stay tuned for the next episode. Thank you, Suhas.
Thanks, Umesh. Thanks for having me. I thoroughly enjoyed our conversation today on getting it right first time.
Same here. Thanks.